Hello everyone, welcome to my videos. I'm back. First of all, I would like to say sorry because I've been so busy in the last few months with the conference, teaching, paper writing, consultation, research, admin work, a lot of stuff. Now I have a free time, I guess. So I decided to do a quick videos. This time it is not about Aspen, it's not about AutoCAD, it's about engineering drawing. Specifically, I'm gonna provide a description on a commercial. Basically, I would like to interpret a commercial P&ID. In this case, I'm gonna try to interpret a P&ID of a pressure vessel. So yeah, let's check it out. The idea here is not about explaining to you what these symbols are, but let's say I'm given this drawing, as you can see on your left here, I'm given this drawing how I would interpret this drawing. This number one. Number two, I would like to analyze what are the important components in the drawing, and then of course, and basically the how it was arranged, I guess. All right, before that, just like to mention that I obtained this drawing from these references, piping and instrumentation diagram development by Moy Togere. Actually, it is a book, quite thick, but what I like about this book is that on the appendix section, they have like probably 20 commercial style P&ID that might be useful for you to interpret. I know in the maybe in the main text they provide like a very simple examples, but I think this in the appendix section is pretty much covers all in terms of like P&ID development. Right, so let's begin. As you can see here, these are the P&ID of a pressure vessel. So what do we have? First of all, as you can see, this P&ID is drawn on a drawing layout, and then this drawing layout has a title block. These are the title block, by the way. Title block is basically a standard block where you provide a non-graphic information like the company name, maybe there's a size, scale, like a notes, P&ID number, drawing number, maybe revision numbers and stuff like that. So it allows, let's say you're giving this drawing to your clients or the contractor, they are able to sort of like get information that are get non-graphic information easily. There are a lot of styles. Some people prefer horizontal. Some people put it like a vertically. Some people just put it small section on the top, on the bottom right or bottom left, depending on the situation and depending on the company. That's number one. Number two, another thing that I would like to highlight here is there's a number on the outer border of your layout here. The outermost line here is your end of your A4 paper or A1 paper, depending on what size of the paper. But on this second line here, these are the your drawing layout. But outside of it, you have a number, right? 1, 2, 3, 4, 5, 6, 7. And then on the horizontal line, you have A, B, C, D until a G, etc., etc. So these are called a zone section. Okay, why is it why is okay? Some company have it, some drawing layout, some P&I does not have it, depending on the again, depending on the style or depending on the format of your P&ID. These are called, as I said, these are called zone section. I mean, you can imagine it like your zone time zone. Like Malaysia is GMT plus 8, and then they have a specific zone. Like on the zone GMT plus 8, you have a Thailand maybe and Singapore. So at that zone, uh, you have a few countries. So how is it relate to this? Okay, in this case, it's called zone section. It basically allows you to identify uh, a certain component in the drawing, especially when we deal with a very complex and large drawing. It allows you the reader to focus specifically on that particular area. For examples, right? Let's say you make a correction or revision on this a drawing, right? So and then in the note section, maybe in the note section you write down maybe for example a gate valve has been added to the nozzle number 4. These are nozzle number 4. And then maybe you write down, please refer section maybe C3, for example. So instead of they looking throughout the entire drawing here, they just specifically go to C3, and then they will see maybe a new symbol has been added. So it allows them to direct, it allows the zone section allows the reader to really direct to a specific section or location in your drawing. That's the second thing. And of course, we have a lot of drawing here, symbols, lines, blah, 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 and also a description. All right. Okay. If I were to describe this drawing, right? So the first thing that I would like to see is I would like to know is what is this unit. Okay, this is called steam separator. It's basically a vessel, and then it was given a name V123. Again, naming of a unit and the naming of the control loops and stuff like that really deep. Even though there's an ISO standard that you can follow, but certain company, like a big company, for example, like Petronas, they have, or maybe ExxonMobil, I don't know, they have their own internal referencing or numbering. So let's say you are given a contract by this company, instead of, in order to avoid confusion, you really need to learn the company's standard internal symbol used, so that you don't, say for example, purchase a wrong safety valve, for example. But basically there are a few but there are ISO standard available for you to refer to. But they generally they are more or less the same. But in terms of like numbering and stuff like that, there could be slight changes, slightly different. All right, as we know, this steam separator is a vessel, so it was given a name V123. That's number one. Number two that I would like to see is my line, inlet line. So my inlet line here, I have these are called stream in, I guess, and then it goes to here, going into the vessel. There's one, and then this, maybe I'll explain later. And then I have another line here. These are my vapor line from here going out to the steam header. And then on the bottom here, I have a line going to the blow down BFW exchanges. But to be specific here, right, if you can see, they provide a description where this line is coming from, because P&ID is basically uh, as you know, you can write down the whole PFD in one drawing, right? But for P&ID, because of its complexity, you have to zoom in at one unit and then provide all of the symbols that will be installed on the unit. So, but we don't really know, for example, where this unit located, in relation to the downstream unit or upstream. So that's why they write down these are, where is it coming from? In this case, this particular inlet string coming from OTSG, B212100 and then 2400. Okay, but I don't know because I don't have the symbol. But another thing that I would like you to refer to here is, you see here, PID 0301001. These are basically in your PDF. If you're given a PDF, this is clickable. So when you click these numbers, it will direct you to the next PNID. PNID of the unit before this vessel 123. As you can see, these are PID 030 and then 1001. And then as you can see on your bottom left, bottom right here, these are the PNID numbering, PD 3001001. It could be slightly different, I don't know, but basically this drawing has their own numbering. But if you want to check the PNID of the unit after that or before that, they have their different numbering as well. For example, here on the outlet, you have a PID 0201010. So if you want to see what's the PNID of the high pressure steam header, you need to click this. It will redirect you to the next PNID. And of course, this one, if you want to see the PNID of the exchanger 2860, it's basically an exchanger where this line will go to, you can just simply click PID 0201010. So that's the drawing, PNID drawing of the E28 exchanger 2860. So I think that's pretty much it for the lines. Okay, this one is Okay, I really not sure what does it mean, but I'm assuming these are high pressure steam. DVA, I have no idea. 14 here is 14 inch, basically the pipe size. 2011 is basically the elevation of your vessel. Where is it located in relation to the ground? For example, here, 76H, I have no idea. Maybe someone, to those who know what does it mean, feel free to write down in the comment section. But before, yeah, I think I probably skip a few things. Maybe we should discuss this first. Okay, these are the steam separator. The size is around diameter is around what 1.6 meters times 8 meters. No, sorry. This yeah, I think so. Uh, 8 meters S to S. No, not sure. Maybe surface to surface. I don't really know. But to those who know what does it mean, let me know. And then this design. Basically, your design pressure is around 11 bar. Is it? Yeah, I think so. 11 bar. These are basically a temperature, maybe a design temperature or something like that. I don't know, but these are your design. Okay, these are quite important to note because we have a pressure setting valve here, which I will explain later. All right, so this line, incoming line, and then these are outgoing line here. Again, HS, high steam, maybe DVA, I don't know. These are 16-inch pipe size. Elevation is 2012, the height, millimeters. 76 H here, not sure. All right, and then you have these are outlet for vapor steam, and it's a condensate steam, and then DVA 6-inch 2035. Okay, now that I think about it, 2035 might not be the elevation, might be the length of the line because these are at the bottom of the vessel, right? So it could be elevation. But to those who know what does this number mean, please let me know. All right, one thing that I would like to highlight here is this these are flank. These are flank. Okay, these symbols we have a what is called these are a field a field circles and then open circles here or black circles and white circles. These are called a spectacle blind. Basically, if you a spectacle blind is like a number 8 ring where one circles on the 8 is open, one circles on the 8 is does not have a holes. Basically, if this line is being used, your spectacle blind will be active. Basically, it allows you to allows the fluid to go into the unit. But let's say, for example, there's a commissioning or whatever, right? You want to close it. What you do is you just loosen the flank connection, and then you simply rotate the number 8 such that the block circles of the number 8 will be will be blocking the pipeline. So these are called spectacle blind. It's very important for you to know. These are also spectacle blind. One, two, three. Okay, we have a 3 spectacle blind. All right. And then in here, right, you will see MW here is called manway, 24-inch in diameters, allowing a person to get into the unit to the inside for inspection, cleaning, or maybe to check for defects or whatever. So these are manware. Okay, in here you have N1 here. I'm assuming these are nozzle number, nozzle number 1, nozzle number 2, nozzle number 3, nozzle number 4, number 5A, 5B. Okay, why 5A, 5B is because these are sort of like these are for level control. This and this are sort of like connected, I guess. I'm not saying connected in the sense that they have 2 holes, but they are being used for control. So they use it N5A and 5B. So nozzle 5A, nozzle 5B. We have another nozzle here, spare. Maybe they want to use it around 4-inch. They want to use it for to connect a new line or whatever. Another spare here, 2-inch in diameter. Another spare. The rest are 2-inch for the instrumentation line. But for the main line, it's around 14-inch, 16-inch, and then 6-inch. And another thing I would like to highlight here is elevation here, EL, elevation from here to here is around 1.5 millimeter. I think these are ground. All right, what else? All right, these are vessel number. These are nozzle number. I already talked about inlet. I already talked about outlet. So I think we can go to the control then. Okay, where should I begin? I think the simplest one would be to talk about this one on the left. So as I said, these are LI. Okay, these are gate valve 3 point. Okay, the size is 2 inch. Pipeline size is 2 inch, but then they have a gate valve of 3.75 inch. This one's probably to relieve the air. Another valve, another gate valve, and then this line is a signal line. If you refer your symbols, right, this line and then dot is a it is a capillary tube signal line, so you should know what this means. So it will measure level. LIT is a level indicator transmitter to indicate level of a liquid in the vessel. So and then you have a liquid go here, liquid go here. They will check the level, and then these are capillary tubing, by the way, and then they will send a signal. Transmitter will send a signal to the level indicator. This symbol is at the DSC, your distributed control system. LI124 is your control loop numbers. HHLL here is a high alarm, LL alarm. Okay, one important thing for you to note here is this one. HHLL is 2800, and then LLLS 305. I think these are indicator of like low alarm, and then high alarm is like very low alarms. The level of liquid should be is reaching 305. It's like too high of a liquid. It's around 2800. I could be wrong though, but that's how I think it is. So this one is done. Okay, let's talk about at the bottom here. All right, so here I have a 6 inch pipe. I have a gate valve here. I have a drain valve, 3.75 inch size. These are, I think, another globe valve, 3/4 inch size, hand operated maybe. And then these are flank where you will have a temperature element, 1 to 4 to detect the temperature of this particular line. And then they will send the element will send a signal to the temperature indicator transmitter located mounted on the unit, because it's just a circle. And then they will send the signal, they transmit the signal. Okay, these are dash line. Dash line here is they send an electrical signal to the DSC to show the temperature at the DSC. And then another one here is this control valve. Basically, these are connected to this line. So these are the same. These are 2 inch what is it called? 2 inch flank or pipe nozzle connected to this 3/4 inch gate valve. Another relief line, I guess, gas relief line. I think 3/4, and then your capillary tubing. This one is a level indicator transmitter 1 to 3. This one is 1 to 4. So they have a different loop number. You have to remember that when you want to numbers. And then the level indicator transmitter will indicate the level, and at the same time they will transmit the level information to the level indicator controller, having a high alarm and low alarm as well at the DSC. So DSC will do some calculation or control, such that if it's too high, okay, they will open this level, this control valve to let the water, the liquid to to uh, to to flow more, so that the level will drop and vice versa. So these are capillary, again, these are capillary line, these are capillary signal line, and these are the electrical signal line. Okay, one interesting, I know in the class maybe you get, or you only have like a this control valve only, right? But in reality, they could be as complex as this. This is not really complex, but the idea here, there's a purpose why they are having this setup. Okay, this one is this one is just a line for your liquid, right? And then these are just a temperature indicator and transmit, and then to detect the temperature of this fluid. Connected to a 2 inch pipeline. So this one is a gate valve. Okay, this one is a drain valve. I will explain later. These are also a globe valve, drain valve also. Okay, this one is a reducer to reduce the pipe size from I don't maybe a 6 inch, from 6 inch pipe size to 4 inch pipe size, because you have a flow, you have a, what is it called? You have this control valve having a size of 4 inch. I think I'm missing one more signal line here. Okay, as you can see here, this control valve has this line where it was pneumatically operated. So opening and closing of the valve was controlled pneumatically. But anyway, so and then passing through this gate control valve, you have another is a reverse of reducer here to increase the pipe size again. You have another drain valve and then gate valve, and then go back. So these are 4-inch bypass valve, 4-inch globe valve, or these are your bypass line. Okay, why does it what does it set up like this? Okay, imagine a situation where your control valve is broken, right? And then you don't want to halt the operation. So how can I do a replacement without disrupting the entire operation, right? So what I would do is very simple. I would close this valve. I would close this valve. And then I would open this valve so that the line, the liquid can just simply flow from here, go to the bypass line, and you can go here. And then since there's a liquid on the line, what I can do is I can open this drain valve to remove all of the maybe corrosive or maybe very nasty liquid from the pipeline before I take out this control valve for maintenance. So that's the use of this one. And then this one, I also have a drain valve here, but it's not really related, connected to this control valve. This one is basically for you to drain the entire line in case you want to do like you want to do shutdown or whatever, stuff like that. So yeah, and then you can install a new one, okay, new one, and then you can close this one, you can open, and then it will resume as usual. So that one is done. This one also done, and then the other one here is we have a pressure transmitter here connected to a 2-inch nozzle, gate valve 3/4 inch, 3/4 inch, and then you have a pressure indicator transmitter to indicate the pressure, and then because it's a circle, it is mounted on the unit, but to indicate the pressure, and at the same time it will transmit the pressure information electrically to a pressure indicator at the DSC, also equipped with a high level and then low level, high pressure, low pressure alarm. So that's it. Here is basically a line for your, what is it called? It is a line for your it is a line for your vapor phase, right? So here they have a FE is a flow element to measure the flow, and then they will indicate the flow mounted on the unit also, and then transmit the information to the controller FS. And somehow they link this information, temperature information, and then flow information, and then the pressure information from the steam header to do a control. I'm not really good with the control. I don't have a lot of knowledge on control, so maybe someone who knows this can provide the description for me. And then I think I already covered all on this side. Okay, on this side, um, okay, these are quite important. Okay, these are called a pressure safety valve or pressure relief valve, whatever. It's for to basically to safeguard or to make sure that your vessel is not getting destroyed in the case of overpressure. If in the case of overpressure, where in this case they use a fire case. Let's say there's a fire, right? And then maybe somehow the pressure, the temperature on the outside is so high, and then it leads to a pressure increase, and to a point where it is above the design pressure of 11 atm, right? Without this may blows up, or it will break or rupture or whatever. So in this case, they install a pressure safety valve. Sizes is one half diameter. I don't really know how to interpret this, but it was set to open at 11.02. 11 at 11 bar, basically the same as the design pressure. So as soon as the pressure inside here reaches design pressure, this will open, pressure safety valve 1 to 3 will open to redirect whatever liquid here, whatever vapor here, to the safe location for venting or to drain if there's a liquid. Slope here is it's not a horizontal. There's a line. There's a slope for this particular line. It is a 6-inch line. Again, I don't really know what's this. VT here, maybe venting, BVA, no idea. 6-inch 2053. I'm assuming this could be the line length is opposed to elevation. Now that I think about it, 38H, no idea. ET, no idea. But in this case, they are connected to a 2-inch pipeline. They have a 2-inch valve, a gate valve, another more valve, 2-inch gate valve, a reducer, two from 2 inch to 1.5 inch connected to a pressure safety valve, and then you have another expander, from 2 inch to 6 inch, and then go, and then whatever gas, or whatever vapors that comes out here after this is activated will be vented out to a safe location, or if there's a liquid here, they will go to drain. Again, these are for fire case. There are a lot of cases when people want to design a pressure safety valve. I recommend you to read API 520 or API 521, don't really remember. So a lot of cases, maybe for example, in the case of choke valve and stuff like that. But the idea here, these are for safety. Insulation, again, they have insulation. This unit will be insulated, so they probably have like a glass wool, something like that on the outside. Okay, these are trim. Okay, now that I think about HSDBA is trim. Okay, I don't know what is trim. BD-DBA is basically a trim. To those who know what is trim means for pipeline, please let me know in the comment section. I think I already covered all of it, so I do recommend you to read this textbook, especially have a look at the appendix section. Very nice. If you know your basics, you should know. You should be able to describe this. Even though, again, if you're given a different format, if you know your basics, should be easy to read. Right, I think that will be all from me. Thank you all for listening. I hope you like the videos. If I say anything that are incorrect, please let me know in the comment section, and I will see you guys in the next video. All right? Okay, bye bye. Peace.